Hey everyone, and welcome. Today we're diving into a really critical and honestly often overlooked risk that any company using robotics is facing. We're talking about that huge, invisible gap between a robot doing something and knowing if it should have been allowed to do it in the first place. Let's get right into it.
So this might just look like a bit of chaos, but it's showing us a very real problem. Right now, as we speak, countless industrial robots are operating without any kind of formal pre-execution authorization. They just get a command and they do it. There's no gatekeeper, no checkpoint to ask that simple question. Is this action actually safe?
And this leads us directly to what the source material calls the uncontrolled execution problem. It's this pretty alarming reality that for most physical AI, there's just no mandatory checkpoint to decide if an action is safe before that robot arm even begins to move.
So what's the big deal? What actually happens when you let this run wild? Well, for one, unsafe patterns can repeat over and over, completely undetected, right up until there's an incident. A single tiny error, that can cascade across your entire fleet of robots. And maybe worst of all, when something does go wrong, there's usually no decision record to even figure out why that action was taken. Every single command just keeps piling on more and more risk.
And this is where it really hits the bottom line. This chart puts it in pretty stark financial terms. The average cost of just one incident, one downtime event, or one failed audit is over $7,000. The key thing to see here is that the cost of doing nothing, the cost of inaction, is so much higher than the cost of putting a real solution in place.
Okay, so how do we fix this? The answer really requires a fundamental shift in thinking. We have to move away from just analyzing what went wrong after something breaks. The industry needs to get proactive and move towards active pre-execution authorization. Deciding if an action is safe before it even has a chance to happen. This slide lays out the difference perfectly. On the left, you've got the old reactive way. Wait for something to go wrong, then dig through piles of data to figure out why. But on the right, you see the preventative model. A command comes in, it's evaluated by this gate, and a decision is made right then and there. Permit it or block it. It's the fundamental difference between reaction and prevention. This quote from the source material just nails it. We do not monitor, we decide. This is so important because it highlights that the goal isn't to be a passive observer or to just generate reports after the fact. It's all about making an active, binary decision for every single action. It's a go or a no-go. Simple as that. So let's be super clear here. This is really defining a whole new category of tool. This is not just another safety monitoring system or a diagnostic tool. What it is an execution authorization layer. Think of it like a license to operate, a mandatory gateway that every single command has to pass through before it can be executed.
Okay, so that obviously brings up the big question. How does this gate actually decide what to do? How does it make these calls? Let's take a look under the hood.
At the very core of this whole thing is what the source calls a six-dimensional motion vector. It sounds complicated, but essentially the system is looking at a robot's movement from all these different angles. Things like, is its path stable? Is it doing the same action consistently every time? Is it moving smoothly? It also flags any weird, abrupt movements or general volatility to build this complete behavioral profile for every single robot. So you take all that complex analysis, all that data, and what does it spit out? Well, it all boils down to one of three very simple, very clear outcomes for every single action. There is absolutely no gray area in the final decision.
First up, you have pass. If the system calculates a risk score below 0.8, the action is considered safe. The gate gives the green light, authorizes the execution, and everything proceeds as normal. This is your all clear.
Next, you've got a warning. Now, if the risk score is in this middle zone between 0.8 and 1.05, the system issues a conditional pass. It allows the action, but it puts some constraints on it, like maybe reducing the robot's speed and flagging it for a human to keep an eye on. This is your yellow light. Proceed, but with caution.
And finally, there's fail. If that risk score hits 1.05 or goes any higher, the gate blocks the execution. Period. This is a hard stop. The action is not permitted, and the system actually provides clear steps for what needs to happen right away. This is your definitive red light.
Of course, for a system like this to really be effective, people have to trust its decisions, right? And that trust is built on two really important pillars: traceability and proof. I mean, just look at this table. It gives you a great sense of the kind of clarity we're talking about. A manager can see the status of their entire fleet in one simple view.
See, Robot Atlas O1 is greenlit with a pass, but Atlas O4 and O5, their risk scores are way too high and they've been blocked, which could have prevented a serious incident before it even had a chance to start.
And this right here is where real accountability comes in. Every single one of those decisions, pass, warning, or fail, is logged in a permanent, auditable decision ledger. And these aren't just some temporary reports, we're talking official records, ready to go for any safety audit or formal review.
Okay, so you're probably thinking, how would a company even get started with something like this? Well, the source gives us an example of their onboarding process, which they called the 4-week decision sprint.
The cost for this sprint is a fixed $7,000. And the source makes a really big point that this isn't some open-ended consulting project. It's a payment for a very specific outcome, getting a complete set of execution decisions for your entire fleet.
And the process itself is designed to be super straightforward. Step 1, the client just provides their existing robot logs. That's it, no complicated integration. Step 2, that data gets run through the gate in shadow mode, which means zero disruption to live operations. And finally, step 3, the client gets a full decision report and that all-important ledger.
And the timeline is fast. We're talking results in just 2 to 4 weeks. The key here is that the output isn't a vague roadmap or a list of recommendations. It's a clear, data-backed report on the real-time authorization status of a company's robotic fleet. It's actionable. Now, it is worth noting that the source material says this initial founding partner deployment is being strictly limited to just 3 companies.
And all of this leaves us with one final, and I think really critical question for anyone out there who operates a fleet of robots. Your robots are working right now, at this very moment, but are their actions truly authorized? Or are they just executing without control? Something to think about. Thanks for joining me.